I don't have all the answers, but I do have some of them, and I have some of the questions, which on our journey we found to be almost more important than the answers to them. And as we've discovered along the way, it's more about the lessons learned. And I was encouraged by that last presentation by the builder at Tice, who talked about how the problems and the things that didn't go swimmingly. And as you'll see today, we'll talk about how to keep you out of trouble, hopefully, on your projects. So the two main themes today, as I have it, is going to be focused on prefabrication and collaboration. And we've heard a lot about collaboration today and a little bit about prefabrication. We'll dive into that as it pertains to how maybe where you would go from here, depending on your level of BIM use, and what some of the next steps might be if you're new to BIM or if you've been using it for a couple of years or maybe you're more advanced in it. Just could I get a show of hands? Let's start with a question here in terms of how many people in the audience here are relatively new to using BIM in their own companies? Okay. All right. And how many of you have been, maybe you've done a couple of BIM projects, but maybe you've just been using it over the last year or so? A few of you. And more advanced sort of power users in the group? Okay, so we've got did I miss anybody, by the way? All right. People that don't like BIM, that you wouldn't be here, right? You don't like BIM? You must be the one attorney in the room. You're going to be out of work soon, you know that? That's what I find. So with that, let's start with prefabrication. This is our prefab shop up in Boston. Most of our work, I would say probably about 90% of our projects, are within 50 to 100 kilometers from our office and our prefab facility. A little bit different from the model here in Australia from my conversations with Mark, a little bit more segmented with the town sort of more spread out. So for us, we're very centralized. It's got a lot of pros and cons to it, and we've been able to prefabricate now more than ever due to the increased accuracy that we're achieving through BIM. And you'll see that in a moment. Actually, I'm going to show a brief video. This is my brother John, who's the president of our company, and this will take you into our prefab shop and what we're doing with this technology. Can we get the sound on there? Thanks.
Hi, my name is John Cannistraro, president of J.C. Cannistraro, LLC, Watertown, Mass-based mechanical construction firm.
Here at J.C. Cannistraro, a construction project begins with its people. Teams of talented engineers, project managers, and craftsmen work closely with the client.
Once that's in place, we can build Platform 3.
But those plans don't just stay on paper. They quickly become a multi-dimensional computerized model through the newest design technology called Building Information Modeling, otherwise known as BIM.
With BIM, the computerized technology that we have, that we're mastering, we're able to show the whole project in three-dimensional, virtual construction, so that the owner can see every fitting, every hanger, every support before the job is actually installed. We're able to move things around, simulate different conditions, and also show the room how it will be for maintenance and facilities operation. It's a great tool.
BIM enables off-site prefabrication even before the project breaks ground. J.C. Cannistraro is an industry leader in the use of this technology and is invested in this state-of-the-art facility to increase its capacity for prefabrication.
Today we're in our prefabrication facility, which we've dubbed the Fab Lab. We're here manufacturing a tremendous amount of HVAC piping for a large hospital in the Boston area.
On most construction projects, piping delivery arrives on the job site and remains unassembled in a stockpile for months. The on-site stick-built method that follows results in lower productivity, longer installation schedules, and greater waste and debris. Bringing the bulk of the work to the fab shop ensures that every component is pre-engineered and installed within a predetermined time frame, thereby improving materials management and the overall project flow. From cutting to beveling to the fit-up. This is an automatic orbital welding machine producing welds of consistent quality. In fact, this 20-inch fitting was completed in less than 30 minutes. Some of these assemblies weigh over 4,000 pounds, but are quickly moved to workstations with the touch of a button and a specially designed crane.
I remember when I was young, we were just like bulls. We'd pull everything around, you know. And this just makes it, you can work like gentlemen, you know, in here.
Foreman Ed Nabadowski has been a welder for over 30 years. He says this facility is light years ahead of the old way of doing things.
Well, this is a controlled environment. In the field, you'd have to land a piece of material into the job. You have to get it up on stands, cut it by hand. Stick welding compared to the FCAW and the GMAW welding is probably, say, four to five times slower than it would be to do it here.
We're able to take months off a schedule for a large mechanical room just by this, because we do 3 or 4 months of work up front before we're on the job. So we're able to take that time, translate it to savings in schedule, savings in cost, and also give the owner a better quality product. The next step is to take this facility, take the skilled labor that we have right here in a controlled environment, and manufacture product power, cogeneration facilities, prefabricated mechanical plants all over the world.
And don't worry, we won't be able to ship anything here efficiently, so we're not actually going all over the world with this. But what John is talking about is the capability. We're trying to set ourselves apart, you know, from our competitors, and we've been pretty successful figuring out this whole prefabrication thing. And it's true that there are tremendous benefits to using BIM, especially in regards to the efficiencies that you gain, the time saved, the money saved, as well as safety, being able to have more man-hours in our controlled environment in the prefab shop, as well as a higher quality with the consistency on those welds, as well as less rework in the field. But imagine if you could take those benefits and amplify them and increase, and you know, sort of more increase the potential for savings. And that's really where the collaboration comes in. So as we go through the 2 themes today, prefabrication, we'll talk about almost like a lonely BIM approach. This is how we started. This is the first step. You know, we heard about don't bite off more than you can chew today. Taking some steps, it's okay to fail, learning from those mistakes. That's really how we got here. We started using BIM by accident. We were trying to go after a job about 7 years ago, and we had just started dabbling in using 3D. We had a guy moonlighting for a video game company after hours. And you know, my brother was like, wow, okay, that's really cool. He's doing all these 3D things. Let's try to see what we can do, and how can we use that to improve what we're doing. And so we started making our first couple of pieces of prefab. And then he's in a job meeting trying to sell a large laboratory project, and the owner says, wow, that's really cool. Can you model my whole building? He said, sure, why not? We're trying to sell the job, right? So about $200,000 later, and about 6 months after the project, we figured out how to do 3D. But really what that was we made all our mistakes up front, I think. You know, we got that learning curve, and that was about 7 years ago. So, I mean, these things kind of happen for a reason, I think. And so hopefully that's a little bit into the prefabrication. The collaboration piece is sort of the next step now, taking what we've mastered in prefab and now looking for ways to grow our business and to collaborate across all the different disciplines in the industry. And we think that we can even provide more value added back to at the end of the day, the building owner, who's our client, who pays all the bills. That's why we're all here. So let's talk a little bit more about prefab and the process that we saw in the video. So this is just another model of a coordinated mechanical room. Has all the level of detail that we would have on a project, including insulation, the springs that we would use, the inertia bases, the pipe hangers, all the information that's required to build this. It's a constructability, all those things have been vetted out. We heard today about building twice, and that's really the way we approach it. We want to make all our issues go away in the model before we're out on the field, where it's a lot more costly to make those changes. We don't always have the luxury of being brought on board as early as we'd like. So consequently, we're preaching all the time, going to events and saying that to our clients, saying it to architects, trying to grow. I was in Chicago last week and I did a presentation on collaboration, very similar to the second half of my presentation today. And I brought an architect alongside with me, Sarah Vicchese from Kling Stubbins Architects up in Boston. And I've gotten to know Sarah over the last several years by working on 2 or 3 projects with her together, with her company. It's no coincidence that they happen to be the architect on the project that we started BIM by accident on. So it sort of comes full circle, but we also worked with her on the Autodesk AEC headquarters in Waltham, Massachusetts. So this is the building where all the software engineers that are working on Revit, that are designing this software and programming Revit, all live in this building. And this was the first IPD project in New England, actually on the entire eastern part of the States. And so it was really a good project to be involved in terms of collaboration. We'll see a couple of lessons learned from that project today. And we'll also talk about ways in which you can apply some of those principles on your non-IPD projects. Because at the end of the day, what we realized on the IPD project was that it was really the start of building a trusting relationship with your peers in these other firms that are involved on the project. Picking up the phone and talking to the architect. I mean, I was on, sharing a discussion here with an architect at a presentation. Not something that I'm used to seeing every day, being part of something with an architect. At least the way our industry is, they keep the subs away from everybody. So that was really quite a privilege to be a part of that, and it really helped share that message. And I think that we'll talk about some of that stuff today as well. Now we're going to track the next couple slides. We'll go through the prefabrication process in terms of what we actually do to track this. This is one individual assembly on this. This is a large hospital project up in Boston. It's the mechanical plant on this project is about 17,000 to 18,000 kilowatts of cooling for this hospital project, and it's about 500,000 liters per second of air changes moving through this facility. So quite a large, complicated mechanical infrastructure project. So this is one component on that project that we manufactured in our prefab shop. There was over 1,000 individual components on this project that we were able to prefabricate. Most of it was all large bore piping just for the mechanical room, which took up 2 floors of a 12-story building. So we have all of the bill of materials here, all of this stock listed right out of the model. But how did we get here? We got here by having the project manager and the field foreman and the shop foreman and the division manager for our HVAC department all having collaboration and communication. That collaboration starts in your company, and that's something that we even realized we were struggling with when we started out. You start somewhere, you start using BIM inside your company before you start worrying about trying to be too advanced with it. Pick a small place to start where you think you can find the most benefit, and also focus on your team building skills within your organization. That's the first step. Here's this piece in the warehouse, in our fab shop. See, I wrote down the weight. Well, it's about 2,000 pounds. I'm not sure. Sorry, about. Anyway, it's heavy. And as you can see, it's rather large. So we'll follow it through the steps here. So loaded up on the truck, we try to organize things in a sort of somewhat of a logical sense. We know that on a busy construction site, there's a lot of ever-changing job conditions, but for the most part, we try to practice some sort of just-in-time delivery so that we don't have a lot of stuff in lay-down areas where it's getting lost, damaged, or people are tripping over it. So that's something we try to think about. Here's the completed installation in the mechanical room. Looks just like the model, right? It's a different job. Total station technology. We heard from Trimble today about that technology, and I will say that we started with one of these machines a couple of years ago, and now we have two of them. And I get calls from other contractors in the area saying, "Hey, can we borrow your Trimble, rent it for a week, or and on this job?" And I can't pry it out of the hands of my guys in the field. It really has had tremendous benefits for us to use this type of field BIM for laying out all of the hangars, whether it be from the slab above or the slab below. We did a project where we couldn't access the floor that we were going to be installing our pipe on, plus the slab was a particularly old building. We'll see it later. It used to be a Ford Model T manufacturing plant. And so all of the hangars had to be fish-plated and hung from the floor above, or some were actually mounted from the floor below, going up with some steel. And so we laid it out above. It was very convenient to do that, to lay it out on the floor above, fish plate it, and drill right down and hang all the piping for that floor for all of those reasons. But it's not just for large piping using BIM and using prefab. This is a laboratory facility that we did for the Genzyme Pharmaceutical Company. And we did all the laboratory. This is all laboratory gas, medical gas for pharmaceutical applications. So same idea. Everything's modeled. And again, that allows us to have the prefab to this extent through the accuracy that we'll be able to get from the models, as well as now sort of having had a few of these under our belt. What do you notice about this image is we've got wheels welded right onto the racks here. This is going to help us later on when we deliver to the site. This is a half a floor of piping for this facility. These are probably over 300 meters of pipe on this one rack. Loaded up on the truck, that represents a whole floor of piping. About 20 different services actually on each rack. So again, we try to do some kind of just-in-time delivery. This was very convenient to be able to wheel these right onto the floor and hoist them up, and we could install a whole floor of piping over only about a day. We had the builder yell at us to slow down. I mean, that doesn't happen too often. Usually the sheetrock's all up, and then we have to put the piping in the wall somehow. We thread it through. Here's your installed utility rack now on the project. BIM Enabled Scheduling. We heard a little bit about 4D today. To me, the way to think of this is not a way to replace your Gantt chart. We actually used the Primavera schedule, which we brought into Navisworks for this using the timeliner feature. So that doesn't go away. But what we used this for was almost like a clash detection in time. So in this particular project, we had some very tight constraints with a lot of the units. it's hard to see on the slide here, but where this air handling unit is right here, that steel is actually going into the air handling unit, and it couldn't be moved. So we had to have a notch in that unit made in the factory that was all custom. And that's a 4-section unit. Each of the sections is the size of a full tractor trailer. So we were only able to do that by basically driving these things around the model. It started out with, in the initial conceptual stages, just to see if it was possible. Started out with paper. We had an intern go down to Staples and buy some foam core board, and he cut it out, and he was playing with his paper dolls, driving around the thing for a month before. Then we brought the foreman in to start looking at it, just to see what was feasible. And then it all got brought into the model so we could do sequencing. And that's really what I'm getting at with the clash detection in time. We have to make sure that, okay, at clash detection at the final resting place for each piece of equipment, each pipe and each duct is one thing, but when the things are so large and maneuverability is an issue, you got to make sure you can get it there. Otherwise, you've got a whole host of other issues. I'll show you a quick video on this too, if we could cue that up, please. So this is the same hospital project that I talked about before. And so you'll see kind of how the schedule is tied in with the actual installation sequence. One of the things here we had to do as well is we had 3 chillers on the project, but there was a 4th spot for a future chiller that we had to coordinate for. It made it particularly challenging because we had to leave access all down that corridor so that the 4th chiller could be brought in a future situation. So we had to make sure that we had sort of a no-fly zone where all the piping was coming down that hallway. As it was, we had to leave a couple of sections with bolted flanges. See all the ductwork, everything, the hangers pop in and then the ductwork pops in, so it's tied into the actual sequence. This is probably not something you're going to do on every project, like the fully rendered images, but there may be a time when you're working on a project, particularly like this, where you've got some really crucial access areas, that it may be worthwhile to undertake this type of exercise. This is definitely not the norm for an approach on a project. What we call professionally executed BIM. My dad is a very avid chef, so sometimes we present this slide and we call this as our BIM recipe. He makes homemade pasta. He brings clients in. We have a kitchen at the office, and he gets up, drags people in at 4:30 in the morning, which is about his operating time, and gives them cooking lessons whether they want to or not. So this is our BIM formula, our BIM recipe. And it's really here to illustrate the point about the differences between your design software and your trade-specific software. And really, this shouldn't be focused on software because it's not really about the software. It's about the means and methods, and it's about the design. The model is. I had this conversation during one of the breaks earlier. I was talking to David a little bit. And when you get the model, from a design model, you really have, different ways, at least we do, of how we would create a shop drawing from that. I'm going to create a shop drawing very differently than one of my competitors is for the same thing. Maybe not drastically different, but there will be differences. I may use a different fitting. I may have a different library. I may like to pipe my steam headers one way, or my coils. I may like to use triple duty valves. They may not. That's sort of a thing that's really shop specific, and that has nothing to do with software, and that has everything to do with the modeler. We have tradespeople for the most part doing our modeling for our shop drawings. And that's the knowledge that gets, it's really a collaborative effort. Again, this is how you get your architect into the conversation. and vice versa. So that's really why we want to try to get involved early, so we can try to get some of those means and methods into the model. So there is this less rework, and the software interoperability plays into that. It's a part of it, and it's getting better in terms of creating less modeling rework, but just some important details to think about. So how much does BIM save? We've talked a lot about what it costs and what the requirements are and how you might start undertaking your endeavors using BIM. We took the last 5 or 6 years or so of projects that we did, all plumbing, HVAC, mechanical, fire protection projects in the Boston area, and it was about $500 million worth of work. A little over 400 projects. And here are the results. You may have seen this curve. I know Mark presented this at your last BIM forum. We'll go over at top circle. These are the 2D projects, the traditional design, bid, build, two-dimensional projects, which even though we started on our BIM journey 7 years ago, it didn't happen overnight. So we sort of phased this out. We haven't done any 2D projects in the last couple of years, but we still had some on the books. And we looked at the change order amounts, and the change order amounts were about 18.5% on those projects. And that represented about $170 million worth of work, of the total pie. Moving from left to right down the curve, you got the middle circle, which is your 3D lonely BIM. And we were using BIM on the project for our own use, whether it be just for prefabrication or coordination amongst, maybe we had a multiple trade project where we had two or three of the trades on the job. But nobody else was using BIM on the project, at least not really thoroughly. And on those projects, which was sort of the bulk of the work over this period, a little over $330 million, the change order amounts were a lot less, about 11%. And there's still room for improvement with this collaborative BIM, which relatively small sample size at 50 million. This includes the IPD project that we did, and it includes that hospital project that we talked about. Change orders under 3% on the project. And people ask me, they say, well, as a mechanical contractor, why do you care about change orders? Why do you want to reduce change orders? I hear a lot of mechanical contractors saying that to me. And, for me, this is the value added. This is why we get hired. This is why we maintain the relationships with our clients. I don't want to redo something twice. I don't want to go and tell a foreman who maybe I've got 20 guys on a job and they just spent 2 weeks working on a section of the building. I got to go tell them now to go rip it out. I don't want to do that. Maybe I'll get paid for it. Yeah, I'll make money on it, and that's sort of a short-term approach. And why not just do it right the first time? Do a bang-up job, build something that you're proud of, make these changes in the model for free or virtually for free. I don't know. This is the internal collaboration that I talked about. So going over all the spool sheets, you got the project manager, we have a modeler, and we have one of our senior HVAC foremen who just retired after the end of this project, who had 40 years experience. Going over in detail all of those spool sheets for the job. They'll even talk to the shop foreman as well. I'm going to talk, figure out how we can maneuver these around the shop, how we can fit them on the truck, as well as get them into the building. And that's really what the trained eye has to be looking at the modeling. You are not just having, people in school that have taken a couple of CAD classes doing the drawing. It's they're detailing detailed shop drawings. It's no different than what we did with a pen and paper, a pencil and paper on Mylar 20 years ago, 15 in some cases. It's just 3D. It's just the next thing. So that sort of brings me into the conversation about external collaboration. So for the next part, we're going to talk about how everyone looks at the building. So can you just get a sense of the mix that we have in the group here? How many building owners or developers do we have in the room today? Okay. And how many architects? A few. Consultants? All right. Builders? A few. Specialty contractors? Okay. And software vendors? They're all in the back row. And how about any equipment or pipe? I know Victolic's here. Any other equipment suppliers? Okay, good group. Did I miss anybody as well? There was the one attorney from before. He hid. Now he doesn't. So I'll have a few perspectives in here. Won't cover everybody, but how everyone looks at the building. Everybody looks at the building differently through this, the same building. We all have a different perspective. There's nothing wrong with that, but it's how we communicate what that perspective is. And in a 2D world, it's a lot more difficult to do than in a 3D world, if done correctly. Because I don't know, I mean, I sit in a meeting and I'm talking to an architect. My background is mechanical engineering, and I'm in contracting. And I'm talking to an architect, and like, I don't understand design. I've never been to a design charrette. And so I have trouble sort of understanding where they're coming from unless I see the picture that goes with it that can really, I really start to understand now what the impact of my systems have on their design, or what the design intent is. And we have the lessons learned as I get into. We'll show some examples of exactly that I went over with Sarah. But okay, so here's the owner, and a little caricature here, but he's looking at the building. He sees he's building. Maybe he sees the tenants. He's looking at a lease. He's looking at the date. He's trying to crunch the numbers, making the budget, making sure everything's going to work for his new building, for his facility. The architect is looking at the spaces and the people coming together in the building and the design. The builder is focused on the schedule, most of the time managing the subcontractors, pulling the whole process together. Big concern about safety, about the whole, everything that happens on site. And here we are as a subcontractor, I'm just thinking about the pipes, like mechanical room. Not really thinking about the design, not really thinking about the tenant unless I'm doing the tenant fit up. Doesn't really affect me, does it? These are all the different visions, and the way to bring them all together is through using the model and BIM and the collaboration. But the solution is not just BIM, but BIM is part of that solution. The solution is changing the way we approach how we do our jobs. Like it's not being afraid to pick up the phone and talk to the architect if you're a subcontractor, or vice versa. Find out what they're thinking. Talk about this shared vision. Now we're all looking at this. We're seeing a laboratory here. We might see some scientists, working on some new drug that's going to help cure people, and so we're providing them with a space to do it. I'm very proud of that. Very passionate about what I do, and the whole part of that coming together in that shared vision is a big part of it. But see, everybody's perspective is still there, and it's important. Because when that tenant's going to move in, it's going to affect, the schedule. But maybe, if being brought to the table early enough, maybe there's ways that, as the subcontractor, may be able to help out with some of the schedule. May be able to do, more prefabrication up front, and deliver it and install a whole floor of piping in a day. If I could be building the piping on the 8th floor before the steels even come out of the ground. So there's ways to do that. My brother always says, good, fast, cheap. You can have two. Only two. Good, fast, or cheap. Can't have all three. But you can have it good and fast. You can have it good and cheap. Get the idea. Lesson learned number one. So this is a lesson learned that came out of the Autodesk project. And as I said before, it was an IPD project. So we were brought on board very early during the design process, and we got the ability to provide input into what this is a exterior perimeter duct detail. This is a 3-story office building, not a very large project. It was probably just under $2 million for the complete mechanical package for the project. It was an existing building, and this was was a brand new core and shell building, so we just came in and we did the fit up for it. So it was completely bare core and shell. So on the left was the detail that the architect had used on a previous project where they had exposed ductwork on a floor, and when they got to the perimeter, they went into a soffit, went from a round duct to a square duct to a flex duct to a linear diffuser, and they had all this sheetrock here. And whatever contractor that they worked on in this project had convinced them that that was cheaper and easier than to just continue the spiral ductwork that was already exposed on the floor and just put a slot diffuser there on the side. So I don't know whether it was in a different market. It was in Pennsylvania. We're in Massachusetts. I don't know. Maybe there was a way that they were more able to do that more efficiently. I don't know. But what I do know is that for us, we were able to save them about $100,000 on sheet metal on this project. And they got another $100,000 back from the drywall contractor for eliminating the soffit. So that was $200,000 that the owner, in this case Autodesk, was able to use in other areas on the project as a value added and get some other upgrades, some other things that they wanted to do. They built a very nice atrium that was not part of the original scope, where they actually cut through all the floors of the building because it wasn't a very high ceiling height, but where you walk in, they wanted to have this great space to show off all of their products and all of the great things that they're working on for all of their, they call it their customer briefing center. So that was made possible in part due to some of the money we were able to give back here through this. Here's what it looks like in the model. And so why is this important? This is important because the conversation that I had with the architect to be able to understand that, the importance of this look they were going for with the exposed ductwork, how that played into the design, how it played into the means and methods of the construction, and all of that was sort of made possible through the collaboration. And so that doesn't have to be an IPD project to do that. Granted, if in a design build project, you're not going to always have the luxury of being involved as early as you'd like, but look for ways. I encourage you to look for some ways that you can provide input on the projects that you're on, or to bounce ideas off your colleagues on jobs that you're not on that you may have worked with somebody in the past, and you're there supporting each other to find out different ways of working through things like this and solutions. It's collaborative relationships build better buildings, and we're all really good at building buildings. It's the relationship part that I know that I need to work on, and that's sort of what I'm discovering over the time here. Lesson learned number 2. Companies build trust through collaborative BIM. So, one of the reasons why now I can pick up the phone and I can call Sarah and say, hey, we're working on this project. Let's, I know you had, this, but what do you think about, changing this around? It's the trust now that we've had a few of these under our belt, and we've been able to sort of understand where everyone's coming from and speaking the same language. Now that we have that sort of rapport. This is again from Autodesk. They had this sort of exposed perimeter that we talked about before, and they had this area in the middle where they had all the offices, and the offices had ceilings in them. And out here where they had all the cubicles and all the windows, that was all exposed. All of the VAV boxes were kind of located in this area in the middle, above that ceiling. And it was a particularly tight area, as you can see here. So one of the things that happened during the coordination process is we we ganged the access for the VAV boxes. So during the design, we were actually, we had the sheet metal draftsman who was doing the shop drawings sitting with the architect and actually, handing all of the boxes in order to make this happen. So normally when we would create the access would just be, an object. We'd figure it out if we do a clash detection on the access, but it would be after everything was selected. We don't normally, get a job where the access is considered in part of the design, but it had to be here because there was really no other space to put the boxes. So that was another sort of value that, being involved early, those are the types of things that we're able to accomplish. Lesson learned number 3, we'll talk about that Ford Motor plant over the next few slides. Early collaboration maximizes the ROI of BIM. This is 640 Memorial Drive in Cambridge, Massachusetts, former Ford manufacturing plant in the 1920s. It's owned by MIT Investment Management Group. It is a core and shell renovation of a building that has housed a couple of different laboratories. This is actually the second time that my company has done a core and shell renovation in this building. The last one was about 20 years ago. And we'll talk about this slide for a minute. I'd like to see kind of what people's thoughts are on what they see here. And I want to hear from some of the different parties that we have in the room. So maybe from like one of the architects in the room, if you want to just tell me what you see on this slide. Who are you again? No? Okay, the one on the right is better organized. How about from one of the contractors in the room? Anybody see anything? Yep. Anybody else want to offer any thoughts on this? That's right. Yeah, the one on the left is a design model. So there's so those are all great observations. Those are all, in fact, true. The one on the left is a design model. It is a different style of pump. As you see here, we were able to go to a vertical split case pump that was not factored into the design. You'll see the pumps are closer together. You'll see we had to figure out how to hang all this stuff. Some of the steel here that we were I mentioned before, we were hanging from the floor. We have all the hangers in here, all the springs, all the inertia bases, things that are missing from this model, and the insulation as well. By doing this, we were able to give about 1,000 square feet of space back to the architect, and for the building owner. That's basically this red area here. By condensing various areas, including the one that I showed you on the last slide. So what that means for us, for mechanical, is, well, okay, I use less pipe. So I'm happy because I had less materials and I had less labor. I looked at this, I took this off, when I was doing the estimate of 1, 2, 3, okay, that'll take that much. And now I know, okay, wow, look, I got looks like about 10% less. But here's the architect now thinking about the space, thinking about what that space means for the building, what that space means for the owner. Now that's space given back to the owner that they can now use for tenant mechanical space. They can lease this space that wasn't in the square footage for their original numbers. And this is the value added back to the project. So this is how the collaboration makes for a better project. If we weren't involved as early on this project, we might not have been able to give that space back in a meaningful way, in a way that the owner could have turned it into rentable space. So that's sort of the implications of these other parties that not necessarily always involved in. Educate others about what you do. This video, my architect friend really liked. This is a video of us installing all the chillers in the basement here, where we had a clearance coming through the entryway of only about 1.5 centimeters. And so we had to remove some of the structural beams, and we had to bring the structural engineer to the table and convince the GC that the building wasn't going to fall down if we did this, because the job was figured on actually, taking the chillers apart, putting them in, but there was a really tight construction schedule where it was like an 8-month job schedule crammed into about 5 months, because there was a tenant that was promised a certain date, and then then it was all of a sudden all hell breaks loose, and the job is just go, go, go. So everything was compressed, and we were just looking for ways left and right to try to shore up the schedule. I didn't really want to show this video when I did the presentation last week in Chicago, because to me as a mechanical contractor, this is just kind of like what we do. And so it's like, it was mentioned earlier about an example where you don't have to necessarily know how the DVD player works or the VCR works. You just have to know that it works. And that's kind of the way I felt that the rest of the industry viewed the contractor. Okay, I don't care how you get the chillers in the building, just get them in the building and you do it. But I showed this video to Sarah and a couple of her architect colleagues, and they were blown away by this video, and in ways, because they said to me, well, we really didn't know exactly how you did what you do, and they found this particularly helpful moving forward in making design decisions. So we're learning from them about the implications of things that we do has on the design, and they're learning from us about how the implications, what their design has on the mechanical equipment. So can we roll that the video real quick? So we had 4 chillers that we had to get into the basement here on this project through this access doorway here. You'll notice there's some snow on the ground, and there was actually a big storm coming later this afternoon, so there was kind of a race to get all of this in one day. Can we just pause it real quick right there? So as you see, it came through. It was just about 1.5 centimeters clearance. We actually were originally going to bring these in on some dollies. It didn't work. We couldn't do it. So we had them on blocks. We had them on some pipe. We had worked with the spray foam insulation contractor to make sure that he wasn't going over the thickness that he had required. I mean, they're usually pretty liberal with this stuff. So in a lot of areas, it was thicker than it needed to be. We made sure that in this area, it was no thicker than the absolute minimum requirements from the project. Go ahead. Thanks. So you'll probably see it's like just. So this is all time-lapse photo. This was an 8-hour day to get these 4 chillers in here. Can you pause it there again, please? So working with the rigging contractor to design and build this structural ramp here that was temporary for the project, working with the GC to get all of the details that went in here. There was no BIM involved in coordinating this. I hate to say it. We used BIM on the job. Yeah, we used BIM to do the coordination. We used BIM to lay out all of our pumps. We used BIM to give them back the 1,000 square feet that they could turn into rentable space. But the model didn't help me figure this out and help our guys. Sorry, can you roll that again? The model didn't help us figure out how to get these all in on this particular job like this. This was just raw experience and collaboration. And that's the key to taking all of those benefits that you can get through your prefabrication and you can get using your Lonely BIM and amplifying them and growing your business and making things like this where we're able to save all this time in the mechanical room because what happened on this project is the rooftop units were pre-purchased equipment and they all came out wrong. So we saved all this time in the basement, and they had this drop-dead date and this compressed schedule. We needed all that time because of the other issues with the rooftop units. So the rooftop units went in 2 months late, and this was done early enough, so we were able to kind of juggle the pieces. You want to pause it again, please? So what else you notice here is these are the pads for the chillers. So as part of the planning, because of the height restrictions here, we had to have the pads split when they were poured. So just another sort of level of detail that, the only way that was caught was, again, through the foreman who had 35 plus years of experience, the foreman that was on this job, as well as the project executive who had about 40 years experience in the industry making things like this happen. And it was the relationships that we had with the general contractor, the builder that we've worked with in the past, and able to bring these other parties like the spray foam insulation guy and the structural guy to the table and making these meetings happen to make all of this successful. Yeah. Okay, roll it again, please. So as you see, we just, one after another. Here are all 4 of them, and you'll see that, they're not wasting any time. Everything's just it's all done by hand. Everything's just cranked in. There's no, no room here for anything but the blood, sweat, and tears of these guys. So again, those were supposed to be taken apart, disassembled, and brought in pieces. So through all this little extra work we did, bringing all those parties to the table and having that collaboration, we were able to avoid all that. So, again, the lesson here is that, yes, we were involved early enough to make all that happen, but we could have been involved earlier and figured all that out and not bought chillers that could come apart. There's some of the waste in the project. Yeah, this is a great success story, but there is still room for improvement. So that I can't stress enough that you can't have early enough involvement from all the parties. How do you, people say, well, that I talk to, well, they don't want to bring the contractors on board too early because they don't get competitive pricing. But when a building owner or developer goes and secures financing for the project, it's long before anybody's brought to the table. You know what the number is. The number you take to the bank, you know what the budget is. You know how much that building's going to cost. So imagine if we could hit that number by being involved early on and designing to the budget and not going over it and not having change orders and having predictability. Well, now you're talking. And that's what we're trying to say. So it's not about just getting the lowest first cost and saying, okay, well, we're going to play this game where, no, we're going to send this out, we're going to bid it to 10 people, and or the whole world. And I did a job recently where we brought an idea to the owner and we said, hey, this piping here and stuff, this is oversized. This laboratory, they were doing so many air changes per minute. They were for a lab building. It's not yet built, but we've been working with them sort of in pre-construction for the last year, trying to collaborate. They're thinking about going IPD with a large laboratory in Boston. And so we said, well, hey, we brought up to their attention that they had more sort of air changes per minute in this lab, about 20% more than sort of what we're seeing with other labs in the Boston area. And so we were able to share that information with them and collaborate and find ways up front where they can kind of, go back and redesign it, because their consultants were from a different, they were in a different part of the country and they were used to different things. And so that was something that we could pick up on that, the other people might not have been able to involved in the project. So those are other ways that, better find that out now, that they can really lower the capacity on all of the HVAC requirements. When you're talking about 20% less air changes, lowering all the capacities of all the equipment and all the piping. Build relationships long term. Align yourself with others that practice collaborative BIM. I think that I'm really impressed with the number of times that I've heard collaboration mentioned today. This is the key from today. It was the key last week when I was in Chicago. we had our BIM forum last week, and the title was, "Where does design end and construction begin?" And I thought that it was going to be the gloves coming off, and it was going to be this, insightful, discussion that was going to get heated, and it was the exact opposite. I was shocked. Now there was a little bit of that negativity in there, but it was it was a very sort of provoking topic, and it was a day and a half event, very similar to this in sort of the form we hear from all the different presenters, and so I'm really encouraged that I'm seeing the sort of the same theme across across the entire industry. Sit at the table together, be open and honest to build trust. Care where the other person is coming from. Don't just do this oh, I don't care, that's the architect. They just want to raise the ceilings. They don't understand how much space I need for my pipe. We'll show them. Sit down with the model and say, well, this is the systems I have. Let's try to find a way that we can give you a little more ceiling height. Let's have that conversation. You don't need a model to do that. And that's why I show that chiller example, where you don't need the model to do that. That's picking up the phone. Educate your clients together. This is, we're finding a lot of times in the States, we're running into people, they say, I want BIM, but I don't want to pay for it, and I don't want this, I don't want that. Well, it's understanding what you're getting. BIM doesn't come in a box. There's all these different things that we talked about today, all these different methodologies that are being used, and it's really about the process. I thought that was a great definition that we saw today a couple of times about BIM as the process of bringing all of this information for asset management throughout the life cycle of the building. And that's really what it's all about, because at the end of the day, we're involved as contractors on the job for just that first part of the building smart curve, the first, 2 years of the job. And then there's another 50 years that building has to exist. So to be able to think about that complete life cycle thoughts of the building, think about the scientists in the lab curing cancer or whatever they're working on, because it benefits the project. Better projects, faster schedule and turnaround for the tenant, more efficient use of rentable space, and future project leads. That Autodesk project that we worked on was with a builder that we had never done any work for in the past. But they called us up and they said, hey, we got this project, and we know you guys are big in BIM, and it has a huge BIM requirement. You're basically using the BIM software by the people that made it for the building that they're going to be working in every day, so we need you to do it. And oh, by the way, it's this new project delivery method that we'll sort of experiment on together. But the relationships that have come out of that, we have a great relationship with the architect after that project. We have a very good relationship with the builder as well. So that's led to a lot of other opportunities, future project leads, and as well as just sort of building that long-term trust. So the last couple minutes, I just want to say about where you might go from here. So if you're new to BIM and you haven't done any BIM projects, I encourage you to reiterate the words before of just starting small, maybe find a pilot project that was mentioned, and find one area, target one thing that you think might be good for your company. If you're on the contracting side, maybe find something that you can prefabricate and maybe focus on trying to model that and learning and because there will be bumps along the way. It will be that stepwise function where it's going to cost you a little bit more upfront and you're going to get the benefits out of it. But as you steadily climb up that process, you'll be sort of into the more intermediate users in the group. I encourage you to continue to do what you're doing, to really focus on now taking that BIM that you're using internally and to be able to start working more on the social BIM aspects of growing your collaboration, building trust amongst your own team members internally as well as externally. And for the sort of advanced users in the group, we got to start thinking of things that we haven't done yet. I'm particularly interested in how the supply chain management is happening down here with the things that Mark has been doing and with all of the initiatives that you're working on. And that's not something that we really have down yet in the States. something we can do a lot better on. You know, when I order a bunch of equipment on a project, I want to be able to get the model numbers and the serial numbers and get that information so that I don't have to send somebody around and collect all that data out on the site. You know, just simple things like that. Get that information. It doesn't have to be in the model. I mean, it's important to put it in the model, but you know, that's sort of the key. It's the information, it's the I in BIM, it's all of these things. The model shouldn't, you know, scare you away from all that. It's just a simple, you know, sort of database. It's sexy. It's the Hollywood BIM, but it's all of that information that has to go into it in order to make it really work for you. So I will leave you with this quote. Remember the Ford plant. Henry Ford said that coming together is a beginning, keeping together is progress, and working together is a success. So coming together, that's a beginning, that's starting to use BIM. The keeping together, the progress, using BIM, you know, internally, starting along the way. Working together is a success. That's keeping the collaboration and growing your business and building those relationships, because I'll tell you what, in 5 years, it's not going to be called BIM anymore. I don't know what it is, but it's going to be something totally different. And the collaboration and all of these things are really what's going to drive the better projects. I was in Sydney the other day for first time. This is my first time in Australia. I've been here for almost a week. By the time I'm done on Saturday, I head back home. And I did a tour of the Opera House, and I saw this video of Utzon, and talking about when he quit the project. This is about, what, 50 years ago now? And he walked out, and it said he was citing collaboration as the reason why he left the project. Now, I don't know all the history of it. I don't know the politics that were involved. I know it took a lot longer to build than it was supposed to. But it really struck me that 50 years ago, there wasn't even a thought about computers for anything other than the space program. And here's a guy walking off a job because he can't collaborate and there's no collaboration. So if there's one thing that you take away from today, the software, the IT requirements, all of this, look through the models and all of this stuff, it's just about the building the better relationships, because this is a people business. And that's what I found. So thank you.